So today we're going to answer exercise 1.34. So under again with chapter 1 and section 1.8 components of vectors. So in the problem, it states that a postal employee drives a delivery truck over a route shown in equation of 1.27. Okay, use the method of components to determine the magnitude and direction of the resultant displacement. In a vector addition diagram, roughly to scale, show that the resultant displacement found in your diagram is in qualitative agreement with the results you obtained using the methods of components. Okay, so we answered this already. Check our video on exercise 1.27 for the the diagram. Okay, for what we call this one, the graphical method. So here we're going to answer this problem using the components of vectors. Okay. So the best thing we do first here is to tabulate, and first is let's make a sketch for these vectors. Okay. Let's label this as vector A, okay, and this is our vector B, and this is our vector C. So if you're going to have an Cartesian coordinate system, this is our X, this is our Y, so we can sketch that our vector A is in this direction, given that magnitude, and we have here our vector B in this direction, and our vector C is located here, which is which is 45 degrees from this positive x-axis, okay, with an angle of 45 degrees. So this is our A, B, C, okay. Using the methods of components, the best way to do this is to, what we call this one, make a graph. I mean table, okay. So we have vector A and vector B, vector C. Okay. So we're asked using methods of components, we're asked to find the resultant displacement. Okay. So next is to list the magnitude. Okay, the magnitude. So the magnitudes are 2.6 kilometers, and we have 4.0 kilometers, and we have 45. 3.1 kilometers. So let's erase this first. So the next thing we do is to find the angle from the positive x-axis. From the vector, from the vector to the positive x-axis, or from the positive x-axis to the vector. So I miswrite that one. And then the x component, and then we have the y component. X components, right? Okay, so from the sketch here, you can see that vector A, our theta A, okay, is 90 degrees. Okay, from the x to the vector A is 90 degrees. 90 degrees. And our B from x to vector B is just 0 degrees parallel to the positive x-axis. And our C is, of course, 45 degrees. Okay. From that, we can now answer, we can now uh, answer find the x and y components. Okay. For example, we want to find the x component. Okay. For the x component, so ax is just equal to a cosine of 90 degrees, which is 2.6 cosine of 90 degrees. So 2.6 cosine 90, it gives us 0. Okay. So 0.0 meter, a kilometer, okay, kilometer. So because it has no y component, 0 because it has no y component. So for the, it has no x component. For ay, so we have a sine of 90 degrees. So, I mean, this is 0. So 2.6 sine of 90. Okay. So we have 2.6 meters because sine of 90 is just 1. Okay. So we have 2.6 meters. Okay. Kilometers. Kilometers. So we have kilometers here. So for our by, so by is 4.0 kilometers cosine of 0. So we have 4.0 kilometers because 4.0 cosine of 0 is just 4 kilometers. For uh, this is actually bx. For by, we have 4 sine of 0. So we have 0. 4.0 kilometer sine of 0 is 0 because sine of 0 is 0. It says that it has no y components. Vx only lies on the x-axis, 0 kilometers. So, so I was wrong about here. So Cx is 3.1. So 3.1 cosine of 45, and our Cy is 3.1 kilometers sine of 45 kilometers. So we have 3.1, 3.1 cosine of 45 gives us 2.2. So this is 2.2 meters. Also, this one is 2.2 meters. 3.1 sine of 45. It will give us 2.2 kilometers. I mean, kilometers. Kilometers. Okay. So maybe I'm going to put the x component here. The x component here, the tabulation here. Okay. So list of the x components and y components. So we have for A, we have 0. For the y components, 2.6 kilometer. For B, we have 4.0 kilometer. And we have 0.0 kilometer. And we have 2.2 kilometer. And we have 2.2 kilometer. Okay. To find the Rx or the resultant component along y and along x, so we have 6.2 kilometers, and here we have 4.8 kilometers. Okay, so those are our resultant components, both in x and y direction. Okay, so now we can find the magnitudes of this. So if you're going to sketch this one, okay, so this is our y, this is our x. So our resultant vector Rx is along this first quadrant because Rx is positive and Ry is positive. Okay. If you want to find this theta here, we can use that. The first is we must find the magnitude. The magnitude of our vector R is just equal to the square root of 6.2 kilometers squared plus 4.8 kilometers squared. Okay. So we have the square root of 6.2 squared plus 4.8 squared. So it will give us 7.8. Okay, 7.8 kilometers. For the theta, we can use the tangent, the negative 1 over the opposite, which is ry over rx. It will give us shift tangent of our ry is 6.2 and our rx is 4.8. I mean, balik, opposite. 4.8 divided by 6.2. Give us 37.7 degrees. Okay. So that is our answer for exercise 1.34. Okay, let's check for our answer. So we have 38 and 7.8 kilometers. Okay. So compare this using graphical method in exercise 1.7. Compare your answer. Okay. So around 7.8 and 37 or 38 degrees. So your so meaning uh, this is your resultant vector, okay, rx, and the angle is 38 degrees. Okay, I mean this is your resultant vector r, and this is the magnitude is around 7.8 kilometers. Confirm this using graphical method. So thank you for watching. Please click the subscribe button and like our videos for more videos like this, for more contents like this. And bless everyone.